Hi everyone. In the last chapters, we discussed how to find live hosts, their services, and their vulnerabilities. In this chapter 5 and 6, we're gonna start phase 2, focus penetration. This is where we're gonna actually enter inside the system we found in the previous stages. So let's just go. The goal in this phase is to get total control of the network, like exploit whatever the services inside, exploit inside the machine, and then make a backdoor to later enter the machine and then find current sensitive information of the system. So to do that, we have to look for level 1 host. These are our first entry points into the system. They have mistakes like bad logins and let us take remote control. So we got the credentials in the last chapters. So we're gonna use that credentials to try to get inside the system and make a backdoor. We have to stay organized by attacking web servers first because web server is the easiest one to look through first, and then we will go to the MySQL part. We chose web services because web services are often the easiest way in. Uh, think of them like a service elevator. If we find the maintenance keys, we can go to any floor we want. Many apps have admin panels. If we get into these panels, we can use their own features to drop a backdoor web shell. This shell let us run commands on the computer through a web page. Like so, in this scenario, in the capsule core environment, we have a Tomcat server running where the manager portal has a default credential, so we were able to log in, and then we can do some malicious thing through that web service. So in this, we had to make a WAR file, which is like a zipped folder with a web shell inside. So once we uploaded that, it's gonna like add a new button to the elevator. So like you will get a CMD command inside the machine while using the web browser. So we can do whatever the commands we want with an like elevator privilege. So that is WAR file upload is like a vulnerability in that Tomcat server. But right now through the web server, we only have a non-interactive shell, which means like a one-way talk. So if let's say if a computer prompt you for like are you sure, so we have to reply to a command, for example sudo apt install a package. So it's gonna prompt for yes or no question, but you can't reply for that through a non-interactive shell like in the web server we will exploit. So we need an interactive shell to make the uh, exploitation works better. So we can just communicate with the shell together. So for that, that's the backdoor we have to use. So to get full control, we use the sticky keys backdoor. Normally, hitting Shift 5 times on a Windows screen runs a help program called sc set stickykey.exe. So since we have admin rights, we will swap that file with the cmd.exe. So we will use our web shell to back up the file and then change the permission using the cals.exe. So, and then when we do the RDP connection, so the RDP connection has to be on the destination machine. So if the RDP is not on, then there's no point on doing the web shell backdoor. So we'll get a powerful admin level privilege CMD inside the machine just using a simple exploit in the web server. So next we'll do databases. So databases is an essential one in all the network, almost all the network. So Microsoft SQL is a great target. So it has a feature called XPCMD shell. Usually, there by default, Microsoft has disabled it due to security features because we can use that to run system OS commands in using an SQL query. So let's say we got like a connection to the MySQL server. We were using that MySQL server. We can exploit or OS commands through that. So this is like a bridge that lets database run commands on the Windows computer. So we have to turn that on and then use that to exploit or make a backdoor or get a credentials. We can do whatever we want. So in the demo, we're gonna use my mssql-cli and then a GUI version called dbeaver, which we're gonna use on Kali, which I will cover in the later part. So first we have to enable the advanced options. Then we have to run the then we have to enable the XPCMD shell from disabled to enable portion. After that, we can just do our who am I and check whether who am I will result you in a user that is currently running the system CMD command. So it will eventually show you the MSSQL's user, and then you can verify whether that user in the administrators group. So when you do the local group administrator, it will show you whether that SQL user is in the admin group. So how does we can steal the password? We can steal the password using hash. So how does Windows handle passwords? So it uses a hashing function. It does not store our real password, so it stores a scrambled version like a hash in the SAM Hive. So as an attacker, we do not need to crack our password if the user has a 64 character password using uppercase, lowercase, symbols, numbers, then it's going to take a lot of years to crack that password. So instead of cracking the password, we get the SAM Hive file and then got the hash file, and then we can pass the login onto the Windows using that hash file without cracking the actual password. So to get these hashes, we have to use reg.exe and then save copy of SAM and system. And then we download them to the local machine, and then we can use the impacket-secretsdump command prompt to extract the hashes for all users. And then we can use those hashes to log in into the system through RDP or whatever kind of protocol we have. So now we move on to the live demonstration of chapter 5 and 6 for the art of network penetration. So we have successfully turned a list of mistakes into real access. We have footholds and password hashes. The next phase is post exploitation, where we use these keys to take over the whole domain. So we just need to remember always clean up whatever backdoor, whatever the shells you have deployed when you are done. Because when you leave those traces, then it's gonna be a trouble. Like the network security system can figure those out, and then they can figure it out like you are in there. So that's it. We'll move on to the live demo. So now let's dive into the live demo. So here we got the index.jsp. So in this file, the it enables the web shell. Like a remote user can, when we open the web shell file through Tomcat, it's gonna open a CMD, and then we enable us to run the commands using Java because Tomcat is based on Java. So We'll upload a web shell. So before that, we'll just the index.jsp file, which has the malware path, which enables the web shell. So after having this content inside that, we will zip that file into a WAR file, .war file web application file. So this command is gonna zip that index.jsp file in a web shell .war file, and then we're gonna upload it on the Tomcat. As you host, go here to the manager. We already got the credentials in the previous phase, which is the admin default credentials. We'll browse here, web shell, then deploy it here, and then it's gonna show it right here. So you can just click on it, and then it's gonna show you the like a typing field. So you can either just type ipconfig. So you can see this like a basic command. This is an uninteractive shell. The difference between uninteractive and interactive shell is like with the uninteractive shell, you can do reply any commands. Let's say, for example, this is a Windows machine. So let's say that's a Linux machine. So you have to do sudo apt install some packages. Then it will prompt you for yes or no to over like confirm the installation. So we can't do that with this web shell. So we have to just run it so that it runs without any prompt. If it prompts, it's gonna fail commands. So we can do it with some tricks, like for example, when we do sudo apt install some packages and then dash y, it's not gonna ask you for prompt. Instead it's gonna just run the command. So we just did this command to check the more instead of like just the information we got from previous phases, which is nmap, we'll get more information. So we had to enable a backdoor. So we now got the access. So let's say like a network team got to get to know like this malware file has been ingested in the web shell of Tomcat. So they'll just remove it. So we can enable a backdoor so that we can go back to the machine at any time without a notification. So right now we'll go here and we'll use the famous sticky key backdoor commands. So this cmd.exe here, and then so we'll first copy the sticky key.exe to a backup file so we can revert back the backdoor once we are done with that machine. And this command is taking the ownership, so I can do who am I here. So it shows trunks, this machine name and the administrator. So some files are like system level, which even a admin can't do anything. So initially, the sticky key.exe has full control only from the system machine, system level user, not an admin user. So as you see here, we will take the ownership here, and then we'll just do this command. It's just one file copied, and then we'll do the ownership. So it says success, the file now owned by trunks administrator. And then we'll go here and use this cals command. The cals command is depreciated as in the book. So we have to use icals command. So it's a bit different than the book. So we are giving full access to the administrative user. So we are already running as an administrative user, but we'll just confirm it with it. So now this file got the so whenever a user gets into sticky key.exe, they're gonna have like the prompt is gonna have like the administrative access. But we're gonna replace the sticky key prompt with the cmd.exe. So sticky key is when you press shift 5 times, it's gonna open up a sticky key. So as you see here, this file we are gonna copy the cmd.exe to sticky key.exe. So it says file copied. So now we have successfully enabled the backdoor. So how to get into the backdoor is the next part. So we can remote desktop it, and then on the login screen we can do the shift key 5 times. So one thing, if the remote desktop is disabled on the destination computer, then this whole web shell thing is a waste. But we can actually run commands, any other commands to exfiltrate anything or like that. but everything should be uninteractive, right? So this is an uninteractive shell. So it's not like there are some limitations. So for this lab, we enabled the remote desktop thing here, but even with the remote desktop, there's a thing. As see here, by default, if you allow the remote connection to this computer, it's gonna check this one. What does it say is network level? It requires level authentication. So whenever someone do an RDP, it's gonna prompt for the username and password beforehand, before even you get into their sign in screen. So you have to enter the username and password. Where this way we don't have any username password for this machine. So what it's gonna do is it's gonna check the password, username, password, check it with the destination machine, and then pass the credentials automatically to the sign-in screen, and then you will automatically get inside the machine, and you will get to see this screen. So with our backdoor, it's not trustworthy, it's not doable because we don't even know the username password. We can get the username and password somehow with the administrator's command prompt or anything like that, but uh, it's better to have an interactive shell and then a backdoor. So for this lab, we'll just disable it and apply it OK. And then we'll go here and then get here. And then we'll do remote desktop to that machine. And then you can see it on the login screen. We don't know the password, but we can just press 5 times. And it got this one. You can see here, you do who am I? You can see we got system level access, which system user, which is more than the administrator user. So this is the exploitation one. So similarly, we can do the same thing with the Jenkins. So Jenkins by default, it has a script console where we can do a Groovy script and then which runs you to the destination machine. So if the Jenkins has a loose policy which enables you to like run some admin commands, then it's going to be a vulnerability. So here we were able to do some system level commands even with. So we're gonna repeat the same thing what we did with here to here. So the destination machine is different. That machine is trunks and this machine is Vegeta. So we'll just copy this command one by one. You can see it's the same command here. So first copying the sticky key to a backup, and you can see the output here. Sorry, take ownership, but you can see the output here. We got owned by the Vegeta user. It's not an admin user, but it's a Vegeta user. This is a command. We'll just run it here. And then it says process file, successfully processed 1 files, failed processing 0 files. And this is the last command, the final and crucial command will replace with the sticky key with the CMD. Just one file copied. So similarly, we go here. We did the same thing with the remote desktop. We'll do our desktop and it goes here. Same thing. We got here. We got a system level administrator CMD prompt. So this was covered by chapter 5. On chapter 6, we will exploit the database server and then exploit the credential hashes. So in this chapter 5, we have seen web server exploits, and this chapter we're gonna exploit the database server. So in most of the companies, there will be at least one database server. So we got the username and password in the previous phase, but we'll just confirm with the MSF console. Get inside the console and then use the no already identified username and password to verify it can log. The credentials are correct. Use auxiliary scanner mssql login. Yes. Said our host and we know the host IP, so we'll just use it. 2.1. Said username sh, set, set password, password once, what's the password, and then we just run it. And it says brute force complete, scan one host, and identified one host. So after we confirm with the credentials, uh, there are some system stored procedures which can be used in a wrong way. One is XP shell. So using that, we can run a system command like an ipconfig or whatever the command using the msql. So we'll send it as a query, and then it will run this command as the user currently logged in, and then output the results in the SQL query. So this kind of exploit is like common, so Microsoft disable it by default. We can check whether it's disabled or not. So we will use MS Console to check on that. Just wait for it. Use auxiliary main MS SQL. Yes. Then the other options are same. Our host 10.0.10.2 or 1. Yes. Use username SA. Sorry, say username SA. Say password password one, and then just one. R host, we forgot to put the R host. Go one, yes, and then one. So it just checks all the commands. So sorry, we'll go up and check to see the XP CMD shell. So which is it's enabled now because only because I have enabled it manually in the during the testing phases before the video. So even though I'll show you how to enable it manually, we can enable it by using the MSF console, but I'm going to show you how to enable it manually. So for that, we have to get inside the SQL client, MS SQL client. So you have to be connected. So we can use many ways. It's using a command prompt or using MySQL SQLi or the impact MS SQLi or using a GUI version, which I'm using here is dbeaver, like it's for Kali version. And you can see here I already added the connection, so you can check the connection, the IP here, and the master is here, and the username and password here. You have to enable trust server certificate, otherwise it wouldn't be connected. So and then it says connected. So I'll just run some basic commands to show, and then we'll get deeper to enable the CMD shell. So this is the command we use to enable the CMD shell. So we are using the SA as the username, which is system admin. So we have the highest privilege in the database. So we just run this. So we click here and then press run. It says configuration changed. So we'll just run this command. Yep, it shows updated. So for we have just like successfully enabled the CMD shell. And after we have enabled, we can run system commands in the MSQL query. Just a simple command to see what kind of user is currently logged in. So now we run like just a simple who am I command using the system CMD shell. So it outputted NT service MSSQL server. So it's a server that uses for the MSSQL Microsoft SQL. So we can confirm this the user that currently running the system commands. So we'll just run this command. So it executed, and then we can see here the MS SQL user is also in the administrator group. So if it's not in the administrator group, then there's no point on doing this. So now we know like the user is in the admin group. So now we have to harvest the passwords. So Windows doesn't store the password in a plain text format. They hash the password, which is like an encrypted method of password. But the tricky part is you can't reverse engineer a hash. So what they will do to authenticate you is that you type your username and then password, and then the same hashing or encrypting function to change your plain text that you enter on your login screen into a hash, and then it check the hash with your data with the database. So this is saved under SAM Hive. So if we get the things inside the SAM Hive directory, we can really get the hash, and using the hash we can use some tricks to get inside the machine without inputting the password. So we can trick the Windows system, like instead of plain text changing it to hashing function, we can directly put the hash and then it authenticate. So this way we don't need to guess the crack the password. If the password is really long or harder to crack, it's going to take a lot of time to crack. So after which we now got the initial access, and then we'll just harvest the password, and then we'll try to get inside the system in the next phases. So first of all, we use this query method to get the SAM and system hives into Windows temporary folder, and then we'll copy that files to this system, and then we'll crack the hash. You see before, like the glitch was like it was prompting for user interaction for like confirm it. So the issue was with that. So I just added /y to prevent the prompts, and then it completed successfully. I'll do the same for sys. Execute. Oh, it's system. Yep, it shows the operation completed successfully. So now we got the file here. Now we enable an SMB server to copy the files. So using the command prompt, we enable an SMB server application, and then we use the SMB into it and then try to copy the file. Before we SMB into it, we'll just make sure the files are completely copied properly. So just run here. You can see, look over here, it's got SAMP 57 MB and then 57,000 bytes, and then you can see system is there. It's around 16 MB. So we'll just enable this folder for SMB, and then we say SMB into it and then get those files. So after we copied and check the file is there, we have to make sure that file has access to everyone, so that when we do SMB and then copy it, because when you do SMB, we have to like, we don't know the username password, so we can't enumerate or like brute force it. It's going to be harder. So we'll just accept everyone to the SMB, make the Windows machine accept everyone. But in the real world, it's rare to have it like that. So what we can do is just do some commands using the CMD shell, and then give access to everyone. Giving access to just for the specific files on the folder to give everyone access, we can just typically give the whole folder to access from everyone to read. So we just run this command. The command from the book will work. If this command works, we just run this command. So as you can see here, it's applied to all of the files. It ran everyone. It can every files inside the directory to access from everyone. And finally, we share the temporary folder using an SMB. This is the command to do that. So that it says I have already done that. It says the name has already been shared. So what we can do is now SMB into it and then get the files. So we just go here, SMB client. So here we are not specifying any username or password. which the machine do Windows usually doesn't. The default version it blocks those things, but we have changed some settings on the Windows machine to enable it. Try like allow remote you anonymous log into the remote user and enable the guest account. So when we not do anything, like when we don't put any user here, it's gonna log in as a guest user. So press enter, and for a password, don't type anything, just press enter with an empty password. It it could take a bit of time. Just wait. So now we got the SMP. So we can do ls. So we just do the ls, and then we can see the files are here. So sys is here, sam is here. We just need both files. We'll just do get sam. So we copy the sam, and then we'll do sys. Yes, we got both of the files. So the next step is to get the credential hash using those files. So in the book, he was using a PW GitHub repo to do it, but the GitHub repo Python file is uses Python 2, but now we are using Python 3, so there's a mismatch, so it doesn't work properly now. Instead, we can use the packet secret dump. So we use the SAM file and then we specify the system file and then we do local. So we just use this command and then we can see the dump credentials, so the hashes. So use this the hash where we can just use this hash to log into that account. So we actually got an admin account here. So we can get log into the machines using that hash, which we'll be doing on the next steps, next phase, the next chapters. And that's it for this chapter 5 and 6 walkthrough. Thank you for watching.